This second task is going to focus in on the idea of recurrence relations kind of in real life, how they connect to real world situations. I do warn you, there will be some language in here which is probably foreign to you. You can go and do a wee bit of research, but actually you don't need to know a huge amount about that language to still access the question. So for example, the value of an endowment policy. Now, that term there is pretty scary and pretty horrible, but you don't actually need to worry about it so long as you can pick out your vital information. So the vital information here is it increases at a rate of 6% per annum, which means per year. So 6% per year, that's our first piece of important information. The initial value of the policy is £8,000. Find a recurrence relation, or write this information in a recurrence relation. So every year we increase at a rate of 6%. Well, how can we write that down? You can choose a letter. I'm going to pick V for value. So V of n plus 1, the next year's value, is increased by 6%. Now, thinking back to everything you know about compound percentages from that 5, that is 1.06 for a 6% increase, times by whatever the previous year's value was. So V of n plus 1, next year's value, is 1.06 times this year's value. The other thing we know is the starting point, the initial value. Now, we'd normally write, if it's an initial value, V0. So V0 is equal to 8,000. Now, at the moment, I'm not going to put the pound sign in because we're just keeping the numbery bits. So this gives us a recurrence relation. It tells us how next year's value relates to this year's value, and it tells us our starting point. And you always need both parts to have a full recurrence relation. We want to use this to calculate our value after 4 years. So now we can set off. We know V0 is 8,000. So V1 is 1.06 times 8,000. I'm just going to get the calculator for that. And looking at the calculator, that gives us 8,480. V2 times that by 1.06 again. So it's 1.06 times 8,480, which gives us 8,988.8. V3 is 1.06 times our previous answer. So let's do that. And that gets us 9,528.128. I'll round this in a second. V4 is 1.06 times our previous answer, which is 9,528.128. And let's do that one. Last one, which is 10,099.815. This is money, so that's 10,099.82. And I'm just going off the bottom there, apologies. So we've worked out our value each year. In our 4th year, after the 4th year, V4, we get this value here. Now, I am well aware some of you will be sitting there going, why didn't we just use compound percentages and times it by 1.06 to the power of 4? Yes, in this example, that works. However, most of the time, the type of examples that you're going to receive are more complicated than that. So let's look at a second one here, and let's consider why it's maybe not quite as straightforward, and also how we're going to tackle it. So we've got 2 pieces of information here about a drug. We are told the patient is injected with 100 milliliters. Sorry, that's my printer's gone slightly crazy there. 100 milliliters every 6 hours. 25% of the drug passes out of the bloodstream. So we've got something about every 6 hours. Some of the thing passes out of the bloodstream. Second thing, to compensate a further dose. Oh, wrong color, sorry. To compensate a further dose of 20 millimeters is given every 6 hours. So we've got this extra every 6 hours. The 100 milliliters is how much is put in to start with. So let's put all of that into a recurrence relation now. So our next hour, well, for the next 6 hour period, let's use D. So the next amount in the dose is 25% less, or 0.75 times the current dose. So the next dose, or the dose in the next 6 hours, is 25% less than the current dose. But then to compensate, we're adding in 20 milliliters. So you can see how the 20 is this amount that's just getting added in. And hopefully you can see how the 25% reduction is like timesing by 0.75. Now that's not a full recurrence relation because we haven't included this information about what happens at the start. Well, the initial dose is 100 milliliters. So D0 is 100. Okay, now, got to be a wee bit careful here. What happens after 24 hours? Well, each time we increase N by 1, that is 6 hours. So we want to find D1, D2, D3, D4, because 4 6-hour periods makes up 24 hours. So D0 was 100. D1, 0.75 times 100 is 75. Add 20 is 95. D2, we've got 0.75 times 95 plus 20. And I'm just going to start doing these on the calculator for ease. So that one is 91.25. Next is 0.75 times our previous answer, 91.25, plus 20. And that gets us 88.4375. And finally, we're doing 0.75 times our 88.4375 plus 20, which gives us 86.328125. We'll give a rounded answer, 86.33 milliliters.